Okay, so in today's video we're going to talk about inequalities. So the first thing that you need to know is that inequalities, so let me write it down. Inequalities are solved as if they were linear equations. That's the very first thing you need to understand about inequalities, and is that they are solved exactly as linear equations, right? So however, there are some exceptions to this rule over here that I'm going to cover with the second exercise. But first, let's begin with our first exercise. That is going to be let's say this one, 1.5x plus 5 halves is greater than 1 and 2/3. Let's do that, okay? So as we would solve normally, how do we solve this? What we now do is that we solve it as if it was a linear equation. Yeah, we do exactly the same. So first we have to, of course, convert these to the same value. So we don't want to have that decimal. So what we're going to do is that we're going to have 3 halves of x plus 5 halves is equal 5/3. Okay. Now what we can do is that we want to isolate x. So first of all, we need to do 3 halves of x times x plus 5 halves minus 5 halves. Okay. And remember that what we do to one side, we do it to another side. So we say minus 5 halves. Okay. This cancels out, which is equal with 3 halves of x times negative 5/6. Okay. So now what we are gonna do is that we are going to divide both sides. Oh no, there's no need of so what we're gonna do now is that we're going to divide both sides by 3 halves in order to isolate x. So this cancels out, and this remaining is x, of course. And so 5 halves, negative 5/6 minus 3 halves is going to be negative 5/9. Of course, I'm not going to I didn't go a lot throughout the process because I have a video covering that covering the process in which we do linear equations. So yeah, I didn't go much over the process, but that's you don't have to worry about it because I have a video covering that. Okay, so as you can see, these exercises are solved exactly as linear equations, with the exception that we have this symbol. We have the greater than symbol. So our answer will be x is greater than negative 5/9. Okay. Now what I want to do now is that I want to represent my answer in different ways. The way we will do this is by showing in two different ways. The first one is a number line, and the second one is something that we call a set builder notation. Okay, so this set builder notation states that the set of all x such that x is greater than negative 5/9. This is for this specific exercise, okay? But that's basically how set builder notation works. So we say in this case the set of all x such that x is so that x is, sorry, I made a mistake, so that x is greater than negative 5/9. Okay, now that we've done this, now that you know how to do set builder notation, it's just a way of representing this answer we have. Now the second way is going to be a number line. Okay, so through this number line we are going to represent these over here. Okay, so now I am going to find now I'm going to place my answer in the number line. Okay, so now the way we are going to represent in the number line is that we're going to set these different values. Okay, so we have, let's say this is going to be negative 1 and this is going to be 0, and now we want to divide it in 7 parts. So 1, 2, 3, 4, 5, 6 and 7. It's not I'm going to do it better. So 1, 2, 3, 4, 5, 6 and 7. Okay, that's a bit better. I'm sorry if it's not perfect. So each one of these is going to be 1/9. So this is going to be 0, so this is going to be negative 1/9, negative 2/9, negative 3/9, negative 4/9, negative 5/9, negative 6/9, negative 7/9. I missed one. Okay, I missed one, so I'm going to use this. Okay, and this is going to be negative 1. This is going to be negative 8. Okay, so now that we have that, we have to place this over here. So let's say 5/9. Okay, so we locate it over here. Now the symbol depends a lot. So this symbol changes how we think of it. So whenever we have the greater than or the less than symbols, what we do in the number line is that we do this circle and we maintain it over there. But when we have greater or equal or less or equal, what we do is that we use a marked circle. I do over there. But since in this case it's only greater than, we use this not colored circle. And what we do now is that we follow this line. So x is always going to be greater than 5/9. So what we do is that this line is going to move over there. Okay, since x is going to always be greater than 95. Okay, so that is the way we represent we represent inequalities in the number line. Okay, so now I'm going to move to a second exercise, and what we're going to do is that we are going to solve an exercise that involves one of the exceptions I mentioned of this rule over here. so as if they were linear equations. So there is one step that I would like to talk about that is important. Okay, so the exercise that we will be doing is going to be x minus 3y. So let's write it down. X minus 3y is equal to 2. No, wait, sorry, it's not equal, is less than 2. Okay, so what we want to do now is that we are going to solve as normal this inequality. So what we're going to do now is that we're going to solve normally. Okay, so since this is one of these equations, one of the equations we saw in our last video about linear equations with two variables, what we want to do is that we want to isolate y. So this gives away negative 3y is greater than 2 minus is less than 2 minus x. Now here comes the interesting part. When we are dividing, so the next step obviously would be to isolate a y by dividing by negative 3, right? That will be the procedure. However, in these types of exercises, what we have to do is that when we divide both sides by a negative number, what we're going to do is that we're going to flip, if that's how you want to call it, flip this symbol over here. Why? I don't really know. However, you must know that whenever you're dividing both sides by a negative number, in order to isolate y or isolate a variable, this applies for inequalities. So only for inequalities, because it doesn't work with linear equations. So when you're working with inequalities and you have to divide both sides by a negative number in order to isolate y or isolate the variable, you have to flip the inequality symbol. Okay, you have to flip that, and it remains that for the rest of the operation. So we follow the exercise normally, and we would get so this cancels out, and we will be left with, since this can no longer be simplified, we're left with 2 minus x divided by negative 3 is equal to y. So remember that it is important too. I'm going to write it down so you can have a reference. When dividing by negative exponents, by negative numbers, in order to isolate, why did I change? To isolate, in order to isolate y, you must flip the symbol. This is something very important to keep in mind, because sometimes the answer to these problems, you may mess up with this part, and probably you would get y is greater than 2 x negative 3, but that of course is the wrong answer. Okay, that of course is going to be not an accurate answer, and you would probably mess up. Okay, so that is a very important thing to keep in mind when solving this type of problems. Of course, now we have to say that for all sets of y, y is greater than 2 minus x -3. Okay, and you can represent it in and remember that these two variable exercises are represented not in a number line but in a coordinate plane. So you graph it and it should give you something like this. And I'm going to go further into graphing inequalities on the next video. Okay, so that is something to keep in mind. I would really recommend practicing with the exercises and reviewing the exercises that we saw the class of let me check here, the class of August 26th. And there are a couple of exercises that are pretty interesting that we did in class, so that's something important to keep in mind. And that was it for today's video. I hope this was a good way of reviewing inequalities, and yeah, I'll see you next time. So keep in mind that the next video I'm going to post that you'll probably see is going to be how to graph inequalities. So I'm going to go over that in the next video, and thank you for watching, and I'll see you next time.